Hey, hey, hey. Here we go again. All right, so before watching this video, okay, let's be clear. So you should have watched part one, and then you should have watched part two, which was creating a scatter plot. Okay, refer back to that video if, oh no. There you go. If you need it, okay? We're going to jump right in, though, to making a scatter plot. So you'll definitely want to pause this and make that. But here we go. So we are going to do a linear regression, and again, there's a couple different ways to do this, but we're going to make our line of best fit on the calculator, right? That is the best way to do this. So here's what we've got. Here is all of your data right here. Latitude and temperature, all right, for a whole bunch of cities, right, around the world: Alaska, Russia, England, Illinois, Arizona, so on and so forth. So remember to name A and B, latitude, B, you don't have to name an average temperature. I think temperature would be just fine. All right, so ignore all of these steps here because we have cooler calculators than the 84, okay? So ignore those steps because it is much more cumbersome and tedious on those than it will be on our Inspires. So go ahead, pause the video, and make your scatter plot, all right? Again, you're going to ignore all of this, right? And then hopefully at the end, we're going to have some awesome equation, right, that we can use, and it's going to be good old y equals mx plus b. So go ahead, pause this, and give this all a shot. Okay, welcome back. Hopefully you had fun doing that. But here's what we got going on. So we're going to do a little bit of rounding. I know we get a really, really, really long number in our calculator, right, for that slope. The y-intercept, the b value, isn't as bad, but it's still pretty long. So a little bit of rounding, right? We can use this equation that I've got inside my rectangle here. And remember, this is now the equation that I can use to predict temperatures for any city, right, that's inside that latitude that we've got. So we can use that to estimate, for instance, the temperature in Vancouver, right? Vancouver has this for its latitude. So if I substitute that value, 49.1, into the equation, a little bit of multiplying and adding, it tells me, hey, average temperature in Vancouver should be 5.1 degrees. Great. Okay. All right, let's make meaning, though. One of the hardest things for us to do is to make meaning out of slope and y-intercept. If you want to try that now, you can. If not, I'll talk through it. Think about your variables. So our x variable was latitude. Our y variable was temperature. So when we have slope, right, we look at our change. Triangle is a fancy symbol in math for change. We look at our change in y over our change in x, right? That's the y2 minus y1 over x2 minus x1. So when we get a slope of negative 0.693, you can think of that as a fraction, if you will. And I know this is the weirdest fraction you've ever seen, over 1. But you can think, hey, for every 1 x value, right, my y value goes down 0.693. So let's put some units on that. Again, x is latitude. So for for every 1 degree of latitude, right, what happens to the temperature? The temperature decreases 0.693 degrees, and we're in Celsius here, I do believe. Okay? So that's the interpretation of slope, which kind of sounds weird, right? For every 1 degree of latitude, the temperature decreases 0.693 degrees Celsius. But what about the y-intercept, right? So we have the y-intercept of 39.11. That tells me, so this tells us the temperature when x is at 0 degrees latitude. Where's 0 degrees latitude? Anybody know? There you go. That is 0 degrees on your latitude. So the equator. So at the equator, so that's kind of our, okay, now maybe it makes a little bit more sense. So the equator, obviously where it's the warmest, 39.11, right? That's its temperature when x is 0 degrees, right? From there, right, that's the warmest it is. It cools off everywhere we go. Okay, cool. All right, let's take a look. I'll let you guys figure out that one. So you can use our line of best fit, our equation, figure out our average temperature in Munich, Germany, 48.1 degrees north. Okay? All right, go ahead and do that. Okay, when I do that, I get that first number you see there, and we might as well round that to 5.8 degrees Celsius. Again, average temperature in Munich. Okay. Time for a bit of practice. Now, here's the deal. I'm going to go through these. Some of these I'll actually pause and have you do. If you want to just pause this and try all these on your own, you can. We will definitely run out of time because I'm going to talk about this and then as well the 2 pages after this, right, that we see here and here. So it's definitely going to be more than what we can get through today, but I think you'll feel comfortable by the end of today with everything that we've got so that you can tackle the homework over the weekend. Again, the homework over the weekend, these 2 pages here, right? The independent practice for 8.3. And yes, we will get to do all questions, front and back. Okay? So let's head back here to where we are. First one says, follow the steps to evaluate the line of fit for the data given in the table. So we've got all of our data that's given here, X and Y. Then we've got it predicted by this, and it just wants us to do a couple things. So I think we could probably, well, we can just do all this together. It's just fine. If you want to pause this, you can. Let's go ahead and first things first, we can make our scatter plot. Okay, so 1 and 3. All right, let's do this. 2 and 6. 3 and 4. Ooh. 6 and 5. Okay, so there's my terrible looking scatter plot. It's really hard to do. Let me draw the line 3/4 x plus 3. So that's going to have a y-intercept of 3. So I'm going to zoom in so I can make a better line, for crying out loud. So y-intercept of 3, and then it's going to go up 3 and over 4. All right. So, okay, so there's my line there. Again, that's not perfectly great. Hopefully you use your ruler or calculator or planner or whatever you got there. Okay. So now we can use that line, all right, to figure out our predicted y values, to then figure out our residual, to then figure out the squared residual. So I will let you fill out the rest of this table. Again, we're using this line that I just drew, this equation here, right? We're using the x values above. So go ahead, fill out this table, and then come back and we'll see how you did. Okay, welcome back. So you'll see I've got the table filled in there, so you can take a look at that to get all your values. If I sum the square of the residuals, right, so that last row, I get 10.62. Question 6 wants me to draw a line of best fit, 3/4 x plus 4. So I drew that in red, right, and then as well, I labeled the other line in blue, the 3/4 x plus 3. That's what we originally had. Then I need to calculate the sum of the squared residuals for this line. Which line is a better fit? So again, now I've got to make a table for this one. So we're going to take this line, and now you're still going to use all of this data, one that we see here, right? But now you've got to make your own table. So if you want to use this margin over here, all right, you can do that, but make your own table on number 6 to calculate the sum of squared residuals for this line. You can't do that until you come up with actual, which you have. You're going to have to make predicted value to then get your residual to then square it. Then you can add them all together. So go ahead, do that. When you're done with that, let's go ahead and input this data here, 1, 3, 2, 6, 3, 4, 6, 5, so we can answer question 7, which is to find an equation for our line of best fit. So go ahead, pause, do that, come back, and we'll have a quick chat about those two things. Okay, here you go. So when you did all that work, you figured out the sum of the squared residuals was 20.62. Our first line clearly was a better fit, right? It has a smaller number, 10.62, so nearly half of what the other one was. If you used your calculator correctly, here is the equation, okay, that we got. Y equals 0.2143x plus 3.857. And if you rounded in there, which again, I wouldn't round, I'd just leave the values the way they are. Maybe you're off by, a unit somewhere. Question 8 says, how can we use a graphing calculator to find the line of best fit for bivariate data? Okay, how can we do that? Well, we can, if I can type here, create a scatter plot on our TI Inspire, and then have it calculate the equation. Okay, and again, that is just through that. You would not, I repeat, not want to try to come up with that calculation on your own. It can be done. It is very long and tedious. Okay, so let's just say best way to do that is to use our friend the TI Inspire for that. Here's what we're going to do on the next 2 pages. This one's actually out of order. We're going to go A, B first, then we'll come back to C. On these ones, I want you to use these for as much or as little practice as you need. Okay? So I'm going to go ahead and I'm going to run these just like we would in class. I would say, okay, hey, go ahead, let's work on these. Again, these aren't anything new. These are just more problems for us to do so that we fully can understand all these crazy concepts of scatter plots and squared residuals and everything else. So when you're ready, all right, unpause the video. I'll have everything on here for problem or page AB on problem solving. All right, then you can move on to problem solving C if you want to as well. Okay, so go ahead, pause the video, work through this. Again, you're at your own pace. So if you get done with everything, you can move on to the homework. If not, just do the homework this weekend. Okay. All right, go ahead and give it a pause. Okay, welcome back. So here's page 1, right? This was the practice and problem solving AB. So I'll zoom in a little bit here if you need to pause it while you can check all your work. So you'll see the 2 lines I graphed in blue and in black. There's all the red points from the scatter plot. Here's our 2 tables worth of values. Right, and then from there we can sum up the square of the residuals to figure out that the 0.5x plus 0.5 was better. Right, it had a smaller number when we compared those two, so 7 and 17 were the 2 numbers I got. The calculator finds the equation as 0.49x plus 0.46. That's not really a good 4.6. That's a 4.6. Oh, there. And does our answer from 5 validate or invalidate our answer on 4, which was our y equals 0.5x plus 0.5? And I would say that it definitely validates our answer. Both the slope and y-intercepts are really close to each other, right? 0.5 and 0.49, as well as 0.5 for the y-intercept and 0.46. So it validates our answer for sure. Okay, if you want to, again, you can give practice and problem solving C a try. So do that, come back, and I'll have everything on here for you, and then we can go over that real quick. Okay, everybody, so here's the ending of it. So here's our last little bit. So crazy long equation there. Graphing this, it's too bad I'm not there to give you guys some pointers on how to graph this one. So again, I'm not expecting you to come up with that, but if your graph looks like that or maybe a little bit different, that's good. Again, the blue line is the line that we would get from our calculator. The R value, I didn't show you how to figure out your R value. You can do that on your calculator too, so if you've played around and figured that out, it'll tell you that as well. But the R value just tells me, remember, that's correlation coefficient. So close to 1, strong, data is good. All right, you can see slope right there. So the number of strikeouts increase each year by this. Y-intercept clearly would be a negative number here, and that doesn't really make sense for us. You can't have a negative number of strikeouts. We would think it would be the number of strikeouts in year 0, but that doesn't, that's way too far away. And then the last question, would you use this to predict the number of strikeouts 100 years from now? I would say no. No, I would not, because it's really far out to do that. So I would not use that. So again, homework this weekend is just going to be these 2 here, 8.3. So give those a shot, and I'll catch that on Monday from you. So hope all is well, and I'll see you guys soon.